So the first thing we want to know is whether there's any liquid inside. And just look over the general condition of the cylinder. And then see if there's any movement in the rod. It's pretty stiff. So I'll have to put it in the vise. This one could be on a machine. You see how it has these trunnions? So it is something that it moves like this, rotating on these trunnions. I get some movement in the rod. Sometimes these little guys have small rods like this, and the rod gets bent, and then it's stuck inside the cylinder. This one here feels like that. Complicated stuff here. There we go. Oh, pretty dry. Well, we can see what type of oil is used. It's red. You see like that? It's water glycol. So it doesn't even use regular mineral oil. It uses water glycol. So it's probably used in a high heat area. So keep that in mind. The type of fluid that is used, so that way when you replace the seals, you know that it's a high heat application. Oh, it's really stiff. I'm going to do this side the same way I did the back, and I'll take off these ones. Probably had it in disrepair for a long period of time with the ports open, so the oil just drains out of it. And the seals are probably cooked. Usually that's what happens. Sometimes guys, they sit around for a long period of time and they sit open, and then the water glycol evaporates and, well, it drains out because it's not capped. On the good side, the stuff isn't seized. Sometimes the bolts and stuff like that get so rusted that you have to cut them off and then get them out, re-tap all the holes, and then get new hardware. The hardware is pretty rusty, so we'll probably just get new hardware. Okay. Make sure the clevis, the thread's good. Doesn't have excessive movement, you know, so that's pretty good. Then you have to measure, look at the clevis ends, make sure that they're still round and not oval, or have excessive play. Something we'll have to measure and check. This is the piston. These are cushions on the back and on the front. The cushion is it's a restriction. So as the piston comes back, the cushion goes into a smaller opening in the gland, and it slows it down so it doesn't just slap when it hits the end. And then when it comes forward, it goes into here, and this restriction causes it to slow down as it comes to the end, so it doesn't just go bang bang back and forth. It actually gets slowed down by the restriction in the oil. So these are very important. If they're undersized, cylinder will just slap back and forth, and that's no good because then it just will destroy the seals and also decrease the life of the cylinder. A little bit. And this is the gland. See, these are the gland seals. And then inside here, we'll open it up. These are the rod seals. So this stops the fluid from coming in and out of the rod, in and around the rod. And this is similar to the gland, but this is called the end cap. You're looking at a pretty small surface area in here. The volume, you know, is probably not even half a liter. Like, it's very, very tiny. Oil cleanliness is very important, right? If there's any contamination in the oil, then that contamination will attack the seals and then will cause the seals to wear out prematurely, and then the cylinder will leak prematurely. Cleanliness of your oil will determine how long your cylinder will last out in the field. So here we do particulate counts and stuff like that to ensure that our cylinders are being tested with the highest quality of oil, to show to the customer that they're getting their cylinder, that A, that it's clean, and B, that it has a good start in life. And then the customer has to ensure on his end that he makes sure that the oil is clean so that cylinder will last long. Now we look down the tube and you see lots of particulate down there. There's no rust in there, so that's a good sign. And that there's no pitting or anything like that. So this tube, we'll have to measure its ID in comparison to the piston, because these have to fit together perfectly. Too much play on here will add stress on the rod. It also will add stress on the seal, right? So everything kind of leads to each other. So if you can minimize the amount of play, minimize your seals wearing out prematurely. Let's say that it's holding, has to stay there and holds a heavy weight, right? Because then the oil would bypass it in these little things, and then the whole thing will come down. All right. Looks in good shape. We just have to measure it. These should be fun to come on. Sandblast all the rust off. We measure these to ensure that they're still the right size, and then if they're still the right size, we'd polish them, and then take all the rust off, and then paint the cylinder. But yeah, we send it back. We don't like to send anything back with rust on it. We like to send it back as new as possible. See this groove here? There's something missing. It's called a wiper. The seal that would wipe the rod so that nothing would end up inside. But it's just deteriorated and came out. All right. That's an interesting. It's been all flattened. I know what kind of seal this is. It would be a rod seal, and the rod seals don't normally look like that. So I'm looking down into here, looking for grooves to see a seat for a seal, and that's missing. We'll have to measure this rod seal and the top here. This bushing should come in contact, or this part should come in contact with the rod bushing, and then there should be a seat. Like this should be able to seat down on something solid, and then we'll have to measure the difference between the space here and here to determine how thick the rod seal is. If you look, let me put this in here. Now this is important. This is a wearable item inside, and I can feel play. You can see there's play there. That shows you that's worn. Shouldn't have that kind of play. And that keeps the rod in the center. So that way it doesn't have movement like this, or up and down, or anything like that. If the rod is good, then that's okay. But we always replace these rod bushings so that they're back to being as tight as possible.
So we'll probably have to send it out to chrome. It's worn heavily on this end of it as opposed to here. This is about half a thou off of 7750, and this is almost 2.5 to 3. So once he cleans up in here and all these other parts, you'll be able to see what kind of clearance we have here. Cushions and bronze bushings, see if they need replacing as well. So, some parts may have to be made. Cushions front, I'll have to verify that once I measure these.
Okay.
Verify the clearance, and then if they need to be replaced, they will be. Also this, just to make sure that it doesn't seem that bad. So. I haven't measured that OD or ID as of yet, but I've got the OD on the bond, so little size of seals. I'll put it in the BOM on the Yeti, and we'll have to just verify this as well. Make sure what this size is, so that when they put their pin in, it actually goes in and doesn't slop around a whole lot. And verify the trunnion sizes as well. Make sure that they're within 2,000. I think that'll be about it. We'll hone this to make sure it cleans up. It's not that bad down there, it's just dirty. So, but there's no scarring. I don't even know if you'll be able to see down there, it's dark. So there's no big scarring or nothing.
You see how there's a bit of a sharp orifice here on there, and then it gets deeper. Yeah. The back had something similar, a little bit less. But definitely that's been hitting this on the way in. The plate here is out of line, and then the piston is trying to keep it in center, and this isn't in center. Yeah, you need a lot tighter fit than that. Shouldn't be that plate. If you could get the end cap perfectly in line and locked and held in place, you might be all right, but it's not going to stay there with any side load.
Well, this point proven without this before.
All this fuss over this little cylinder?
This was circling back to the point of if we had taken it apart and knew that the end caps right away were going to be worn, plus having to machine a rod. Between the labor alone, we're looking at probably $4 grand to do everything, and the parts, which is why we would have just quoted to build the cylinder from the bottom up. There's a lot of intricate machining involved with these end caps, especially these. That's the main concern.
Yeah, I'll see if I can get that seal out, but it looks,
Something's rubbing that.
it looks shot.
As if that came brand new from Seal Tech. We should have never installed it, that's for sure.
1520. 10 thou.
Right. Confirming what you already knew. Or thought you knew. But that, you were talking about this, so that was this fit onto this thing here, right? So, I mean, you're looking at now having to replace this?
Yeah, with this being out of line, then the cushions will hit as they go in, because everything's not.
How do we know that once we machine this, we don't find some problem with barrel as well?
I think they measured it, the barrel was good. Is it straight?
That's a pretty beefy piece to get out of alignment.
Just got the bolts in here a fair amount of play, so if we got any side load.
So it could also be a combination of their machine as well.
Yeah, or even when we put it together, when you torque the bolts down, you will pull that up, down, sideways.
Who made this piece?
This is the original.
Everything's original. The only thing that's been machined so far was the new rod and then the cushion.
Oh, did we make this?
No.
They deemed that the tube was okay and that the end caps were okay.
And
Piston was all right.
but we've determined that the end cap is not okay.
So we have 3 thou clearance here, and we have 10 on this. It could be out more than we lose our clearance in the cushion going in. So ideally you'd want 3 thou clearance here, at least 3 on this, so that this would never hit.
So if it does shift or something's blocking.
Awful lot of work for a small little cylinder.
Well, that's usually the ones that create the most headache. The
No.
ones that you would assume.
Unfortunately, they've all created headaches for us. Would it be reasonable just to be making sure that they're consistent? Like, could you just? Is there a reason why one would be different, or if this one is 3 thou and this one's 10 thou, very clearly they should at least both be 3 thou or both be something.
The bigger and more volume of oil you have, you might have a little bigger clearance, but on the back we're actually smaller. If anything, it would be tighter.
Okay. What I'm saying is, even without him knowing much, could he at least infer that if this is one, then this should at least be somewhat close?
That's pretty good.
So without even having to make large assessments and analysis, right there.
I would assume both to be very close.
Alright, so we got rod seal damage. That's what's in there, right? In the end cap.
The end cap seal, yeah. Oh, and I didn't get that out yet.
That's the rod seal, right? That's all.
Yeah. Nobody's looking. How do they say? Do not do this at home?
Do not try this at home, kids. Is that because it's the wrong size, the wrong fit, or is it just assembly procedure?
It might just be an assembly procedure. See if this could be flipped the other way and if it would.
Yeah, see if it actually has any cylinder.
I just find the wear on that a little awkward.
Aggressive
Awkward for new pistons. It's like it's.
Yeah, I mean, because it was only cycled what? How many times?
Yeah, not very often.
And there's already that much rubbing going on. That seems
In
a
some
little-
spots and not others.
Yeah. Somewhere along the lines of inspection and assembly, something was missed, and back to the drawing board to see what could be going wrong causing these issues.
It's bronze. And it's replicating the original part that was undersized. I believe that is 1/8 thou under what they would need to have it work, or the new one will be just like this, but 1/8 thou bigger on the diameter. Find the tap without much of a search. 40 minutes maybe. It's pretty quick. Finishing the roughing aspect of it. I'm threading it, and then it will actually go on the shaft, come back for a finished turning. Take it over for the shaft fitting. Has a little dressing to do still, but basically that's it.
It's right there. All this. The piece de resistance.
Couple things, just want to make sure.
Okay.
This looks different.
It is.
I took it apart, it was a mark, we've had it apart so many times. Can we check the drawing and make sure which end is?
Yeah.
We'll just start at the beginning.
Yeah.
And then I actually have a couple ideas for assembling it, maybe to line things up.
Okay. Yep.
But that would be the first thing we got, is getting the rod seal on past the threads. We may have to come up with a little trick or something.
Okay. So we can't do it. We can loosen this. We can take this off, put it on. Yeah. That's the way to do it. That's what we're gonna do. We're gonna take that piston off. I'll have to just be careful. We'll probably have to heat it up because Mike had already put Loctite. Well, there's one extra. It's for tear because you just have one for the back cap, one for the gland. Then you have a rod seal, goes in there, and a little wiper that goes into the top. Loosen that off, then I'll be able to back this off, pull that off, and I can build the gland, put the gland on first, then put this on. And then that'll stop the rod seal from going over the sharp threads. On, right? This whole thing just unscrews, pulls off. The gland will go on this way, and that prevents the rod seal and stuff like that from getting marred up on the head.
Brilliant idea.
But he put in, it's on maybe an hour or two ago, he put in a little bit of Loctite, so I'm going to have to apply a little bit of heat, and then I'll just back it off, and then I'll just take it off, and then we'll go from there.
Yeah, because going over here is going to be
You
very
won't be
tough.
able to do it.
No, it's the same size as the rods.
Yeah. And
Yep.
I've tried to put them on even without in the gland, but then you can't get the flared ends in. That's the easiest way.
Towards the
The
rod.
gland. Okay.
Yeah, I also checked the drawing, a picture.
Okay.
So yeah, we'll do that first.
Okay.
Get the rod seal on.
All right. least you know the piston will never fall off. You have to spin around quite a few times. There we go. There we go. Just going to soften this edge right here because I'm going to, when I put the gland together, I'll have to go over that edge. And we don't want it to have any sharp pieces. That feels pretty smooth. Okay. They're all good now. That feels okay. Sharp edges.
Yeah, like you say, you're going with the flow of the seal now.
Yeah. Okay, that's pretty good. The U-seal will be easier to color there. Just wondering if this was too square, but the wiper is flexible enough to go over it. Make sure that these surfaces are nice and clean, so when the O-ring goes on, it doesn't hold up on anything and bypass. These guys, and get pushed in there like that. And then this guy goes on top like that. This is what I'll never see. That way, in the future, when you go to take it apart, it's not all seized. There we go. And you put on some O-ring lube. Piston.
You want to put these rings on first, maybe? Might be easier rather than going all the way across.
This is the front. I took them off the front, so it should be all right. Like, because I have to jump over the first one anyway.
So this goes on top. Yes, that's quite obvious.
I'll just put some emery cloth on this.
A little bit.
Yep.
Okay, try that.
A little looser. Okay. There we go. That's perfect. There we go. You can't over crush it. That's why we put the Loctite on there. And once that hardens up,
Good? Or you want to just throw it all?
that's good. Okay.
With this actually located on the cushion,
Okay.
that will center this on
Yep.
the rod.
Yep.
put the bore on, put the bolts in, snug them down a little bit.
Yep.
And then move it and do the back end.
Okay.
Because there is a little bit of play.
Piston in, and then that'll keep us as centered as we can get.
Yep.
And then we'll bolt the front on. And then once the front is settled, we can push it forward, and then we can put the back
end.
on.
Yep.
Okay, gotcha.
So
Key to putting these on is not breaking them. These ones are light, so they're easy. These are called cast iron rings. They're piston rings. Seems a little loose. It comes off like that. That off. Okay, so long
To the rod.
long to the rod. Okay? So if we load it up like this. Okay, if you could hold the top just like that, Tom.
Decent.
Okay.
Okay, we'll do the same thing again. We'll pick a different spot here.
Yeah.
So if we get the solid part at your end in first, if you push it in.
Okay, it's in, yeah.
Okay. Okay, now we just gotta get, okay, it went in the second part.
Yeah.
As long as I don't pinch your fingers.
There she is.
The more you get in, the easier.
Yeah,
seems to
yeah.
get. Okay, we gotta come down a bit. Watch
Yep.
your fingers. Okay.
Okay, so now we got the pressure in it. Okay.
Felt good.
Yeah. Alright. So, we want to put a bolt in here and then we can pull the rod back?
This needs to be lined up with that like that. So we'll get a little bit of grease on there and then we'll maybe get this put into place. Yes.
Yeah. So I can just get it down so
A couple bolts started. And
there we go, and then we can just pull it
the
back.
rod back up. Yep. Got to the end.
Let me
Tough to get that in.
the back cap on. We were going to see if we could test it with air, but because it's got those cast iron rings, we can't build up enough pressure because the air will bypass because it's got the little gaps in the rings. So we're going to have to test it with oil, and we'll measure the stroke length to ensure that it's going all the way in and coming all the way out. Because if the cushions don't line up, when they go into the hole, it could stop. And then it'd change your stroke length because it's not going all the way back. And same thing when you extend. If it hits the cushion on the other side, if it doesn't go into the hole, then your stroke length, your extension would be short. Well, first you find a fixed point on your head here. And so I can measure, say, like from the face here to here, right? When I know that it's closed all the way, and then I'll extend it, and then I'll measure from this face to this face, and then I'd subtract the first one from the second one, and then that'll give me what my stroke length is. Make sure these fittings are tight, and then we headed over to the bench and running the particle counter for the oil.
It's about the same size as this, but it's got